So first cab off the rank, it's 7 AM Monday morning. So, you know, got the Monday voice. This one came in last week. Good old Blues Junior. Everyone's seen one of these. And a lot of arc damage, mate. Smoke, soot, some kind of fluid leakage there. Yeah, some other tech had a go at this. So I had a quick discussion with the customer, bit of a backstory. I played up, he took it to the technician about, I want to say 3 months ago, and he repaired it and it blew up again, caught fire in a dramatic way, smoke came out of it, horrible noise. And I said to him, why don't you take it back to the previous guy? And he said, well, he did that kind of work, I don't trust him, I'm not going to take it back to him. And that kind of sucks, because if I didn't do something schmicko 100%, like if there was a tiny little rustle in the background or anything, you could bet that customer's back on my front door, right? So this guy kind of got away with it. He charged the guy, and I don't know how much, but he charged the guy, did some really shoddy work, and you'll probably never hear from him again, but he got his money and didn't have any consequences. So let's run you through what he did, and then let's do it fucking properly, eh? So, zoom in. Arc damage. How's that? Too far. So he's joined up those two, well, what have we got here? So he's cut traces. I'm gonna have to pull out the circuit and have a little double check of this, but that trace used to go through there, that went around that, so that shorted to that. He's cut this trace, diverted it with a really heavy wire, like way too heavy. 600 volts rating though, that's nice, isn't it? So then he's hardwired directly from that valve pin to the spade connector, but instead of buying the crimps and doing it properly, he just soldered to the spade connector, and I can't get it off because it's welded itself to it from the arc. So we're going to desolder that and replace it with a proper, well, we'll see if we can melt the solder and get that off and just clean her up. I think I might have some of these PCB spade connectors in the thing. I really don't want to go doing a special order for that, if we can avoid it. And we're going to rerun all these, well, we're going to replace the circuit board. We're going to pull out one of those circuit boards I've been raving about. So that's a perfect contender for one of these little bastards. So these are some I got made. I think I mentioned them in the past. Blues Junior replacement valve board, 2mm FR4, so a bit thicker. This one's got a fair bit of flex to it, this one not so much. 3-plated holes, that's the most important part. And check out the comparison with where the ribbon cables go. So they've just got round pads, no isolation slots. I've got oval pads to get more surface area. They're also through-hole plated, so stronger in that respect. It's also 2-ounce copper, so the copper's twice as thick, if not more, and that allows you to make the traces narrower, so you have even more isolation. And where was I going with that? Well, it's better. It's betterer, right? So I've also put to just check the bias on each side for the guys that are a bit too sketched out by doing the output transformer shunt method. You can pop some little 1 ohm resistors there if you want, and then you got a handy little test point right there for each each valve to just directly tell you, with a 1 ohm resistor, directly tell you how many milliamps is flowing from each cathode. So that's the little chucha. It goes all the way up to the preamp there. The heater lines are top and bottom of the board instead of next to each other, beside themselves. I'd be beside myself if I was one of those tracers too. I've put them directly in the same area on the top and bottom of the board, just to aid with the heater hum rejection. Yeah, so we're going to install one of them. Use the existing ribbon cables because they looked not too bad, and we'll get it moving. So I think we'll remove the chassis. I'll also want to do that just to show you how to do it without destroying stuff. So we'll zoom back out here. So the other thing this guy did, which try and figure out their way of thinking, I don't know. The owner wanted a auxiliary speaker output, right? So he wanted to use an extension cabinet. This is an 8 ohm speaker, and there's only a single 8 ohm winding on this transformer, so nothing's going to be ideal. You can generally, if you're not pushing it right to the limit, you can sort of step one way or the other without a massive issue. If you're really pushing the thing into solid output overdrive, you really need to match the impedance though. So the only option there would have been get, say, a 4 ohm one or a 16 ohm one in here and a 16 ohm one in your extension cabinet, and that way you're back to 8 ohms, but only when your extension cabinet's plugged in. So if you want to use this by itself, the only other option is to plug in parallel resistance, just DC resistance, just so the amp's seeing the same, at least DC resistance. But what this guy did was put in this thing, he drilled extra holes in the back panel and just mounted it there. It's got like a neon power switch. It's a Lumberg style jack, a bit of metal he had lying around, which he soldered to the steel. It's an interesting way of fixing it. I guess he didn't want more screw holes in the front. Seems to be reasonably sturdy though, but there's no electrical connection there, it's just mechanical. Yeah, so he's put a resistor, 5.6 ohm 5 watt, in series with the auxiliary speaker. So I guess what he's trying to do there is just limit the amount of load on the output stage, so at least you've got, you know, probably it'll probably make it an effective about 16 ohm. I guess that's what he was aiming for. And then he's got I just don't know how these guys' minds work, you know. It's like they're shit-faced when they work on amps. That's the only reason I can think of doing this. It's like they're shit-faced. It's like they don't turn up to work unless they've had a fucking schooner of scotch. So anyway, he's got, instead of using a spade connector, I mean, soldered to these, yeah, fine. But he's got a spade connector insulator. After he's soldered it, then he's slathered it with hot glue, and then he's tried to put a quick connect, a spade connector insulator over it. Hasn't been able to, so then he's just gone, oh fuck it, and just put it there. Same with this one. Like, he's glued shit, and he doesn't trust spade connectors, so he solders them as well, and then he puts an insulator on, and then he glues them. I just don't know. I just don't know why do they do it? Like, just go do something else. Drive a forklift. You'll make more fucking money. Trust me, I know. So anyway, this is holding on by a strand, and yeah, there it goes. And then the Lumberg. So all of this is going in the bin. That's what I'm saying. If you want an extension cabinet, get another amp. Basically, it's not an amp built for power. All right, it's an amp built for practice, recording, small live gigs. Anyway, I digress. Power on to the soldering station. More coffee required. I've got the jazz in the background, just loud enough that I can hear it, but not loud enough that I get a copyright strike. We're going to replace this lead because these plastic things suck and they all fail. I'm going to test the foot switch. We'll take that out. Oh, it's held in there by its little Velcro. That's alright. Oh, I already had a board in there. So we're going to just remove all the detritus. I might remove the chassis, as I said, just to show you how to do that. Because a lot of these amps have a lot of damage on the inside here. I know people like Lyle and that repeatedly tell everyone, but these techs don't listen. They just keep doing stuff in a very not ideal way. So, side screws, back them out. Back them out before you even take the back cover off. These were already out by a 1/8 of an inch, just so I could remove the back cover, because the back covers, this one's not as bad, but the back covers, they're made out of MDF. Got this very thin section here. See right there? You pull that too hard, you break it there, and it holds on by the fabric, but it's always wobbly and just crap. It's another source of rattling. So you loosen off the side so it's not clamping on the edge of these boards, and you can remove it reasonably easily after that. That's odd. Oh, that goes into the metal chassis. So you can see here's 2 screw holes there. Not a lot we can do about that, but whatever. And just put that aside. Let's remove all of the things in the stuff. So there's the cute little bugger. Ubiquitous amp. They're bloody everywhere. That's what ubiquitous means. Tiny transformer, tiny output transformer. This front panel's actually pretty good condition. It's not that old an amp. But yeah, the special limited edition or whatever they call it, it's just because it's tweed. There's no difference at all to the amp. It's got the exact same boards, exact same everything. So Fender have started releasing new versions. Like this is Hot Rod Deluxe number 4. This is number 5. This is number 3. They're all the same. There were some differences between the first and second, but it's just marketing bullshit. They've got this exact same components, the same factory errors, the same unreliable areas. That's identical. There's no difference. So there's a lot of people going around saying, "Oh, all those reliability issues have been sorted with version 4." Wrong. You're like, mine works fine. Yeah, but it's 2 years old. You use it once a week. Alright, snip the stuff off out of the way. Snippity snip. It's kind of hypnotic watching that flux smoke go into the little funnel there. So, board removed. I'm going to take those standoffs off and reuse them. I've reverse engineered this thing so they all line up perfectly with the chassis. We're going to mount them on this board. We're going to remove the sockets except for maybe socket 1, which has arc damage. Sorry, socket 5, V5. That's one of the EL84s that's got arc damage on it. Not real keen to use that in case some tracking's happened within the material. And what's the $2 Belton, you know, so, but the rest of them are fine, no evidence of burning. You can see there actually damage has happened within the board, like it's heated up that much that it's blistered the fiberglass on this side too. Alright, so we're just removing the little standoffs. They've got a little Loctite material on there or something, but it's not very hard to break. Might put a drop of red Loctite on there afterwards, just because it is a combo and it is hanging right in front of a speaker. So we'll reuse these standoffs and they suit the perfect height for those belts and sockets. So at the end of the day, I've seen people mount the valve sockets directly to the chassis and hardwire them and ditch these things, which is doable as well, but it's, in my opinion, it's much more time consuming. And then you've got to use new sockets. You can't reuse these ones because they're PCB Beltons. You've got to drill holes, mount them. You've got to run your heater wires to every valve. It's a lot more work. I wanted just a drop-in replacement where you could buy the board, bolt it in, just wire the ribbons up to exactly where they were, and bang, away you go. And that's what it is. So let's remove these sockets. Alright, so we'd probably be alright to use that socket, but for a bit of peace of mind, we'll just replace it. You can see the carbon there from the board burning. Doesn't look like there's any tracking actually occurred in the socket itself, but we'll just change it out to be safe. We'll use the rest of them though. Alright, now the board is slightly thicker, so you've got a bit less of the pin protruding through than on the old one, but there's still plenty there. Oh, I just knocked them out. Alright, there we go. I've just soldered 2 pins on each socket. Let the solder flow to the other side. Yep. Try and get some fume extraction happening. Next socket. Right, now what I do is just get your hand under it now that they're all secure. Just reflow one joint while pushing down on the socket to make sure that it's fully bedded in, and then do the same on the other one. Sometimes you feel it do a little pop there where it seats itself properly. There you go, little pop. That one moved a bit too, just to make sure that they're mechanically seated as low as they can be against the circuit board. Sweet as, then we'll solder the rest of them. Give you a close-up action shot. I won't say money shot because I'm very mature. So this 2-ounce copper will have a bit better a chance against the heat generated by the valves. Having said that, we're also going to cool the bias down because these things run ridiculously hot for a fixed bias amp. So we'll change the value of the resistors in the resistive divider that forms the bias supply to find a new bias voltage and therefore a new output dissipation in its idle state. That's a long way of saying we're going to adjust the bias. I've got a feeling that the initial damage from this might have been caused by a shorter valve, and the damage that occurred this time, I think the valve's okay, but it was just his failure of his solder joints and stuff that causing the arcing. Having said that, I'm going to pretty thoroughly check those EL84s. They look to be groove tubes, which I think is what this thing came out with originally, so they may be original. They may have an intermittent short. He may have just put the old valves back in. You don't know. You've got to assume the last tech was a complete fucking nuffy. Because if you assume they knew what they were doing and there was a reason why they did what they did without reverse engineering what they did, you might be giving them a bit too much credit, and then you get the same reputation as them. Right, so now we're going to transfer the standoffs just literally straight over to the new board. You could have gone crazy with like 3mm FR4 or something here, but then you wouldn't be able to use the old standoffs. Want to make it so you could use the old parts, repurpose them for the new board, and just have a higher quality board. So we're not tightening the living fuck out of them, because remember they are just 3mm screws. They're pretty easy to shear off if you had your wheat bix that morning. Oh, I just realised you probably won't know what I'm talking about. You had your wheat bix. It's like Popeye with spinach, right? Makes him strong. That was an advertising campaign for a wheat-based, I guess, breakfast biscuit. I don't know how to explain them. You guys probably have a similar thing, but it's called something else. Alright, there's our new setup. One thing we've got to do yet is put in some 1 ohm resistors. You can use links if you don't care about cathode measurement. I'm just going to put them in anyway for fun and to show you guys. So 1 ohm, 1%, 1 watt, 111. Alrighty, so we've got one down here, straight in. One resistor. Two resistor. So we've put in the bias sense resistors, 1 ohm, 1 watt, 1%. 1%'s a bit, actually I think they're 5%. Yeah, whatever. Yeah, 1%'s getting a bit anal. So what I'm going to do now is make some little test points out of the offcut of the resistor lead. I mean, you can just use bus wire, but this just happens to be right there, and it's just the right gauge and everything. So I get my little lead forming tool, just make a loop. Like so. Nothing to it. Just put that little bugger in. Just so you can put a little IC clip around it. It just rotated when I heated the solder up, so I'll just move over that. Hopefully I'm not too shaky, having not had breakfast yet. One test point. Cut off the excess. We've got a little loop there to just get your IC clip onto. We'll do that again for the other one. 2 test points. They're nice and safe. They're never going to have high voltage on them, so even an amateur checking the bias of his new valves, it's reasonably safe there. Of course, there is high voltage nearby, but not on those connections. So what we're going to do now is give her a bit of a clean, deflux. I'm going to drink some more coffee. So flux is, if it's good quality solder, is insulative, but it can over time absorb moisture and it just looks shit. I like having repairs look really good, so you see them and it's just to the untrained eye it looks like a professional job, because first impressions do count. So what I'm going to do is get some alcohol, not whiskey, Elaine, and just let it sort of soak into it. Give it a bit of time on there. Let it mature like a fine whiskey. And then we'll give it a scrub. Right, so I've noticed this is another set of tools that not many techs have, because you see all sorts of hacked up ways they get around owning one. I can understand why, it's fucking expensive. The handle itself was like, I think it was like 280 bucks. and then the dies are like 160 each, and the dies will do say 3 different size wires with one type of connector. So you see there it shows you the connector 2.8, 110, and then all the different wire gauges. So if you're using that connector and you're using from 18 to 22 AWG wire, use that one. If you're using 22 to 24, use that one. 24 to 26, use that one. There's really not a lot to it other than that. And with them, this is ratcheting, so it won't let go until it's crimped it properly. It's literally, it won't undo itself until it's gone to its maximum, wrong way, to its maximum force, and then it lets go. Which one have I got? Just pull that lever and it comes out. Got a 6.3 in there, which is what I want. 6.3 millimeter wide spade connector. So we've got 2 damaged ones, and we've got, oh, we've only got 1 damaged one. So we only need to re-crimp the brown cable. That's the output transformer primary. So I'll zoom in and just give you a look at the process. So I've got, where are we? 6.3. That's the one. So that's what the connectors look like before you crimp them. Zoom out a bit. So that's the bit that makes the electrical connection to the wire, and that's the bit that spikes into the jacket to mechanically hold the jacket as well as the wire, so it doesn't pull the jacket back. So yeah, we'll just strip an area of that wire. There's enough slack on it that we can get to it okay. No more burning on there. There's a bit of soldering iron burning, but what's a Blues Junior without someone having burnt stuff with their soldering iron, eh? So you only want to take off about 1/4 inch, if that. I'll speak in inches for you Yanks. And then I like to get the thing started. So just see there, just get it in, hits the end, it starts to do a U-turn. Now that's ratcheted, so it won't let go, it'll stay in there. Get your wire in there, make sure you don't get any pubes turn around on you. When you see the wire protruding for the other end, start your crimp, eat your wheat bix, and there she is. Alright, I didn't bother putting an insulator on that because none of them do in the factory state, and all the connectors are sort of on their own, they're not right next to anything, so yeah, that's simple as, and you just need the equipment to do it properly, which it seems almost nobody has. So, now we've got this shit show to deal with. Alright, so the wires the ribbons are in reasonably good condition, no melts. It's just a lot of carbon on this one, and that should clean off fine. I'll just get a couple of cotton buds. Bit of alcohol, and yeah, that's coming off okay. Just give it a few cleaning cycles. Yeah, it doesn't look like there's any damage done to that actual ribbon connector, it's just the smoke residue. Use the bristles of the brush to get down in the bits where the cotton bud can't reach. It's still got its flyback diodes, so unless they've gone short, they're good. And we'll heat up this spade connector and fuck it off. Just crank up the temp a bit there. She's sizzling away, she's angry. Yep, now it's coming. There we go. One burned as hell. Spade connector. Yucky. So we've got to remove the board anyway. It's not that difficult on these ones really, you just got to remove the speaker jack. Let's do things properly, eh? Alright, so the board's mobile, we'll get the LED pilot light out of there. Just give us a bit more give on the board. Just let go of the little reverb gland there. So we've got some give on the reverb cables. And we should be free now. Let's see. Whoa! Well, that looks worse than I expected. There's no arc damage on this side, but that's all smoke residue from the other side. So what I think's happened is there's been a high resistance joint there because of the shitty way that he soldered to the crimp that he couldn't remove from the spade connector. So that's created a lot of heat in that area, and it's actually set fire to the plastic, the PVC jacket. And these are the little wispy bits here of carbon. That's burnt plastic. So yeah, good connections do matter. So we'll clean all this up. Don't think there's any tracking in this area, it just looks like soot. So yeah, let's get another paper towel in there. Paper towels, paper towels. It's sticking pretty good to the steel. I'm going to remove that spade connector just to give it a good clean. A bit more solder. That solder's cooked. That's another thing actually, looking at the solder joints, they're real crusty, so that the spade connector itself has gotten hot. That's always evidence that something's either drawn too much current or had a really shitty connection, because that connector would have been dissipating energy because it would have been a high resistance joint, and it's not really built to dissipate energy. Alrighty then, let's reinstall this. We'll clean that board area. Looks pretty hunky-dory, man. It's that area's going to look like nothing ever happened there, which is what we're after. Leave no trace. Not leave no traces, like some techs. Leave no trace that you were there, except for a bit of a giveaway. That's good, that's a trace we do want to leave. So we'll reinstall that spade connector. A little headery type thing. P3 it is, that's a brown connection to the output transformer. And pin them over a little bit like they had. Solder them in place. It's well seated. Alrighty then, let's well, we've got the board out, we're going to do a recap, because fuck IC caps. So we're just going to snip all them out. They're not siliconed, are they? Yeah, they're siliconed. Yeah, it's letting go pretty easily. Alright, snippity snip snip, snippity doodah. 47 microfarad. Of course I checked these for voltage before we open the amp. What do you think, I am crazy? Just work them sideways and they let go just gently. You pull them off, you end up punching yourself in the face. So we'll get rid of that residue. Well, let's remove everything that we're changing first. So C1 we're going to change the value of so that it goes bye-bye too. I'm going to get me little chisel out and we'll scrape away some of this silicon. I like this brush because it's got this little end on it. And if there's any real stubborn bits of shmoo that won't let go, you just flicker over and it's nice gentle timber. Just remove that little bit and scrub away. Right, so we're good to go on that one. Get rid of the silicon, get our new caps ready. So this chisel here, which I've modified, that's not your average grind on a chisel. This has got a convex grind on it. Well, not technically convex, but you know what I mean. It's bulges that way. That is normally what I use for certain luthier jobs, like where you use it like a little planer. By changing the angle of your hand, you're changing the amount that it wants to bite in by. It's sort of like changing the planer depth on a block plane or something. With a hollow grind, it's not as accurate, and they're sort of meant to be used the other way around. So I use this because it's great and it works like a little bulldozer to remove the silicon. And never cut towards yourself, okay? You'd think I'd be cognizant of that after putting a knife through my foot the Christmas before last. Nice and clean, bro. Do a little smear silicone underneath, bugger all. You don't want it splooging out everywhere. Leads softly bent, no hard turns, slight curve on the leads. I don't bend them right over because you can rip pads when you remove them eventually when this cap fails. Could be, I don't know, 2 decades. If those leads are folded right over, it's really hard to get under them and lift them up while heating them without lifting the pad. So I do it like this so you can at least get a desoldering gun or something onto the end of the lead. I don't bend them over at 90 degrees, I bend them over at about 45. Just because I like other techs. Fully sick, bro. It's a nice looking morning out there. I wish I wasn't in the shop. Oh, it's 10 to 9. Gonna have to open soon. Oh, customers. I love them. Wouldn't be here without them. Right, so they're soldered in. The only thing left to change now is the bias resistor. Bias divider resistor. Which is, I just realised this is not labelled as a Blues Junior 3, but it's circuit, the component designators are as per that schematic, so we'll have a look at that instead. We've got R51 33K. Fuck it, I'll show you the schematic. Copyright be damned. We have the technology. So, check it, yo. Here's the C-, that's the bias feed to the output pair. That's the cap, stabilising the output of that. That's the resisted divider, so that's pulling that off the, well, what will become the -15. There's the regulation for that. That's the Zener. That's the resistor loading the Zener. That's your divider that determines the voltage here. So 33K, 22K. Now, changing R51 to 24K has been the closest shot in the dark so far to get you where you need to be on those output valves. That's a pretty significant value change. You're almost talking, what, you're talking, you know, a third of the value. So we'll do that and we'll see where we stand, because as you make that a smaller value resistor, it's going to drag that C- closer to the negative rail, which according to this is 26.5 volts. As you increase that value, it's going to swing more towards ground, which means less negative on the bias and more dissipation in the output stage. So let's try 24K there and we'll see where we sit. R51. Alrighty then, let's get this board in. So we'll just check the ribbon connector ends, make sure they're not frayed, and they all look pretty good. I've given, on the first revision of this board, I only made 5 of them just to test. The holes were a bit too tight for the ribbon connectors, so I increased the size so we can easily get them in the holes and not get any little pubes going out at right angles touching the neighbouring wire. But yeah, it is a little tricky. If it was easy, every prick would do it, eh? Just use a tweezer. If there's one there that's not playing the game, you can just direct that one wire in. You can look at my bald head in the meantime. Right, so we've got the new board in place. We've got the heater wires, everything in there ready for soldering. We've got the test points installed. Got the bias sense resistors installed. So we'll just go ahead and solder the ribbon connectors and should be ready to bolt back in. All the standoffs are lining up, that's good. More or less. What I should have done, what you do in these situations is don't cinch any of them down yet, just so the board's got a bit of play in it. You can move it around by a 1/2 mil just so everything can line up, and then once all the screws are 90% in, you can go through and just torque them up. Won't bother with the reverb just now, we'll just make sure everything's stable and then check that after. First we'll just have a listen, won't worry about the dummy load just yet. I want to hear if there's any hum or buzzes or anything weird, so we'll plug the speaker in. The valve sounds awfully rattly. We'll see if that manifests itself as any oscillation or microphonics. We're powered up. Just double checking everything, you know, visual check, make sure nothing's no wires have let go, nothing like that. No caps have been, no components have been squashed, or no wires have been pinched. Doesn't hurt to just check the thing over by eye several times. We're looking good, so let's give it some signal for now through the signal jetty just to see that everything's working, and we'll put the meters on each side of the output stage. We've got our fancy bias resistors, so we'll use them. Otherwise you can use the output transformer and take a reading off that once you've measured the DC resistance. We'll find a convenient ground point, which is the ground. I might latch onto that cap, it's a bit easier. And if you're going to do that, make sure it's not an amplifier that's got a pair of series capacitors, because you'll be half B+ voltage in that case, which is not good. Latch onto our test point on the circuit board with our 1 ohm resistor in series with the cathode on both sides, so we can see when it starts conducting. We'll switch over to millivolts mode. Might chuck another one on there just to measure B+. We can calculate our bias. We want plate to cathode, not B+. We want it on the plate connection, so choose one side and then we'll switch it to the other. What I'll do for that is I'll just put a ground lead on the chassis and put a probe in so we can probe around. Right, master down, reverb down, volume down, fat switch out. Let's fire it up, give it a go. We're on 0 volts, which is really more like, well, let's tell you. And the main's coming in. Wakey wakey. Helps if you turn it on. So 0 volts on the Variac is more like 5 volts AC. Alright, so let's slowly ramp it up. We'll keep an eye on the power. There's 5.7 watts there, which is the energizing power for the Variac. It pulls 5.7 watts when nothing's plugged in. We'll bring it up, coming up to, I'll just monitor the AC where we're going. 25 volts AC, 6 watts. It's not running away dramatically, so we don't have a hard short. 10 watts at 67 volts. Coming up to 110 volts. 15 watts. Oop, fuck. Made me jump. That was an arc in the output valve. Was it not? So I think we've got a shorted valve. Yep, see that? So, we do have a fucked valve. Let's turn the lights off, I'll show you. Romantic. So let's watch some arc action. Watch this valve on the right. We're only up to about 110 volts when that happens. Oh. That might be a heater short actually. Let's not do that again. So yeah, let's change the EL84s, eh? And -8, so we're getting negative supply. That's good. Let's just chuck those new valves in there and we'll see how she do. I did factor in a new pair of valves here because I assumed that the damage that had occurred was either due to or would have damaged the valves as well. Alright, let's go again. Slowly bring her up. Starting to get signal. Drawing 16 watts at 130 volts. And I'm back. So let's give it full voltage. Clench our teeth. Bang. -12. That's gone up 40 milliamps per side, so that's still a bit warm. It's interesting actually. Volume control's a bit scratchy. In the meantime, I think we'll look at cooling this bias down a bit. By my calculations, that's still pretty hot. My head calculations. So what have we got? We've got say 325, 328, 326 on the plates. So that's over the design spec for an EL84. And we're pulling about 38 millivolts, 38 milliamps, sorry, on one side, 35 on the other. That's reasonably well matched, but still a bit hot. And what's the mains voltage today? 243 volt. So yeah. Alright champions, so we've got the Blues Junior up and running. I changed the screen grid resistors, upgraded them to 1.5k, which I forgot to do initially. Giving it a test, we've got the plate voltage on here, we've got the direct anode current there and there, so we're actually breaking it up and using the milliamp meter in the multimeters there to measure directly the anode current. Using my little bias tutors, little probes I made. You can see them there. Got a little circuit board which I fabricated and a socket on top. The leads are going a bit crazy, so I might put some little heat shrink ties over them and keep it under control. But everything's behaving. It's running a little bit warm still. It's around 77%. I've checked on the scope, there's no oscillation. It's just still a bit warm with those values that we normally put in, and it gets it bang on every time. This time it's still a little bit warm, so I might try another set of JJs and just, they are very well matched though, as you can see. Don't know. Just gonna have to play with the bias divider a little bit further and change the bias point. So let's give it a play. Straight away you notice the bottom end's a lot tighter. In those tiny little cabs, you pump too much bass into them and it just flabs out and you lose a lot of detail. You can't get that much bass out of that little cab anyway. With the volume about 12 o'clock on the bridge with the humbucker. Go up to about 8. Up to 10, which is like, yeah, 3/4 of the way there. Bring the volume master down a little bit, probably clipping the mic a touch there. Volume all the way, gain all the way. Go back down to say 10, it goes up to 12 these ones, just the number scale. So the fat switch adds a bypass cap to the second stage. So you get more bottom end and more gain. So there you go, champions. I'm going to cool that bias down a little bit more, and then we'll just give it a bit of a burn in on those valves, make sure everything's staying hunky-dory, and we'll put it back in the box and send her off. Just give you a quick demo of this thing, eh? up pretty nice. Just try not to completely wipe out the microphone. Just take it off axis a bit, see if I can open her up a bit without making the mic lose its mind. Another one down, another one bites the dust. See you on the next one. You know where to find me.